not sure, right?
That's-
No.
Well, would it be negative because it's negative I?
So we have a negative I. So that second term, you'd be looking at inverse sine of that. You get negative, so let's write it out. Square root of 26 times 5 over the square root of 26 minus 1 over the square root of 26 I. Now, if you do the inverse cosine of that, you'll get 11 or negative 11. They give you the same thing. Cosine of negative 11 is the same thing as cosine of 11. So there's no way from the cosine to tell the difference. From this minus sign, though, that shows up in the second term. And if you do the inverse sign, you'll end up getting negative 11. Okay. Suppose you're not sure what sign to put on a number. Here's a useful graphic that you'll find helpful. And I think, to some extent, for those of you going on in electrical engineering, you'll find this indispensable. When looking at a complex number, think of it like a two-dimensional number. It's almost like a vector. It has a real component and an imaginary component. We'll graph the real component on the x-axis and the imaginary component on the y-axis. So the number 5 minus I will be looked at as that point right there. So it's over 5 and down 1. The angle that we're getting here is that angle right there. So this angle and that angle correspond to that angle on the picture. So to get it, I can either do inverse cosine of 5 divided by the square root of 26 or inverse sine of negative 1 divided by the square root of 26. So when deciding if the angle should be positive 11 or negative 11, making a little graphic like that might be the fastest way to figure that out. You also could have done inverse tangent of negative 1 divided by 5. That would also probably, the calculator would have given you the negative 11 for that. Okay, so these are my A and my B. I'm now going to divide them. When I divide, I subtract exponents. You know, if you have x to the 5th divided by x squared, that's equal to x cubed. So if I'm dividing numbers with exponents, then this will be e to the I times 56.3 minus negative 11.3 degrees. So I'm just subtracting the exponents. And what goes out in front would be the square root of 13 divided by the square root of 26. Square root of 13 over the square root of 26, which gives me the square root of 13 over the square root of 26.
Radical 2.
0.707 e to the I, and then what's left here, 67.6 degrees. And now finally I can convert that back using this relationship. E to the ix is cosine x plus I sine x. So I have 0.707 times cosine 67.6 degrees plus I sine 67.6 degrees, which is 0.707. Cosine of 67.6 is 0.38. And sine of 67.6, I get 0.92. Sine of 67.6.
Yeah.
Okay. And finally, my grand finale answer, I would just distribute the 0.707. 0.707 times 0.38 is 0.27, and 0.707 times 0.92 is 0.65. So A divided by B is that. Let me summarize. To find A divided by B, we had one way of doing it. I could use the conjugate. That was Isaac's suggestion. Method number 2 seemed like a lot more work only because it involves this transformation. I first take the two numbers, write them differently, divide. After I divide, I get this, and if I wanted, I could transform it back into that version. This process is very similar to what you would use for the Laplace transform, to solve a differential equation.